right, so today we're going to start our introduction to 5.1. Before we do that, we want to talk a little bit about chapter 4, because I want you to remember that everything we did in chapter 4 is still going to be true and applicable in chapter 5, but in chapter 4 we focused on values as opposed to identities. So in chapter 4 we would have said that cosecant is really 1 over sine. So this is really going to have to be 1 over 1/2. Or you could have just taken the reciprocal and said sine theta is equal to 1 over 2. So you flip both sides, and that would be acceptable as well. So we need to label theta, and we label our angle. And so now I want to come over here and I want to say, okay, well, that's 1 over 2. Now for that same theta, for the same angle, we know that the tangent of theta is equal to square root of 3 over 3. Well, this is really a rationalized denominator, so I'm going to unrationalize it. Okay, so tangent, according to identities, is opposite 1 over the adjacent 3. Now I can use both identities, or I could have used the Pythagorean theorem. It doesn't matter. I'm going to get the same answer. 4 minus 1 is equal to 3, so square root of 3 is what we have here. Okay, so now I want to find all 6 of the remaining values if I can. So now keep in mind I have cosecant and tangent. So now I look at the sine and I get 1/2. I can look at cosine and I get square root of 3 over 2. Cotangent is just going to be the tangent flipped. And then the remaining is secant, and secant of theta is going to be cosine flipped, so 2 over the square root of 3. And that's how we would have done it back in chapter 4, sections 1 through 6, I guess. And so we want to take this information and we want to use it again, and let's see what happens here. So again, we're finding the 6 trigonometric values if possible. Well, I already have 2, right? So I want to make my triangle because that's how we do it in chapter 4. So I'm going to come over, grab my triangle, and have a triangle. And then put in my right angle. And so label a theta. So there's theta. And theta, or x in this case, let's call it x. So the cosine of x is square root of 24 over 5. And now with just that information, I can use the Pythagorean theorem to come up with the third leg. Or I can recognize that the cosecant of negative x is equal to negative 5. Well, that's going to require me to do a little bit of thinking. So in my thinking bubble, cosecant of negative x. First thing I want to remember is, what did a negative angle mean? It meant I went down. So this angle would be a negative x. And I'm told that the cosecant, which I know, given my identities, is equal to the adjacent over the opposite. So the adjacent leg over the opposite leg. But that's for x. Okay, so we're going negative x. And so what I want to do is I want to think about what is cosecant. And cosecant is really 1 over sine. So this is telling me that the sine of negative x is equal to negative 1/5. Well, sine is opposite over the hypotenuse. So now that's telling me which quadrant I have to be in. And it turns out that I was given the other leg here. So when I'm looking at this cosine of x, I want to take a look and say, well, that means this is positive x, equal value right there. And so this is saying that for this value, this is the square root of 24 over 5. Okay, well, the square root of 24 is the leg shared by both. So now I have all 3 legs of this triangle. So now I'm going to go ahead and keep the negative x, because that's telling me the down angle. So there's the negative 1, which means this one would be 1. But remember, I want to look for where the sine is negative, and sine is only negative in 2 places. Since cosine is positive and sine is negative, that's going to narrow it down to this quadrant right here. So right here, there's my triangle. Okay, so I want to make sure that's good. So cosine is positive and sine is negative. Perfect. Now, given these legs, 1, 2, 3, I want to find the remaining identities. So I know sine is negative 1/5. And I know that, now, do I need to keep this negative angle here? No, but remember, for sine x, if I say negative x here, that's the opposite of the sine. So I can use this as well. And we'll talk about those identities in a second. But for now, we're going to go ahead and go with this. So when we look at the negative x, we get a negative 1 here. Now, I have to choose whether I'm going to give my identities for x or for negative x. So I'm going to choose. I'm choosing to do quadrant 1. So quadrant 1 means I'm going to take this triangle, and I'm going to go ahead and I'm just going to flip it so that it's in quadrant 1. So I'm going to put my x there. And I'm going to put my square root of 24 there, and my 1 is going to be here. So now everything I do, I'm going to do for x. So I want the sine of x, not negative x. Okay, so all my identities have to be related to the same angle. So the sine of x is opposite over hypotenuse. I already know the cosine of x, so the tangent of x is equal to the opposite over the adjacent. And now I'm just going to flip that. Cotangent of x is equal to the square root of 24. And then I need the cosecant. Nope, I need secant of x. Secant of x is just 1 over cosine, so that's up here. It's going to be 5 over the square root of 24. Okay, so those are the 6 identities. Okay, and just so that we're clear, the cosecant of x, cosecant is 1 over sine x, so 5 over 1. Okay, here's the tricky part here. I'm given this negative angle just for the purpose of drawing the triangle. But remember, I'm either going to solve all 6 identities for negative x, or I'm going to solve all 6 identities for the positive x. I chose to go with the positive x because that's what we're going to be using. Okay, let's do one more. This information is given to us a little different. This right here is telling us that the tangent of theta is negative. Okay, the tangent of theta can be negative if and only if the top and the bottom have different signs. Okay, that's the only way that can happen. So we want to come over here and we want to remember that the secant of theta is really the reciprocal of cosine. So what this is really telling me is the cosine of theta is negative 1 over 3. Now, I'm going to tell you this. Remember, your hypotenuse is always a squared length. So that's always positive. So in this case, we are being told that the cosine is negative. The only place cosine can be negative is when I go this way. So I'm thinking quadrant 2 or quadrant 3. Okay? So that means sine has to be positive. Well, now that narrows it down. I have to have my triangle here because sine has to be positive. Okay? Due to this restriction right here. That is telling me sine of theta must be greater than 0. Okay, so I want to draw my triangle. So this is negative 1, this is 3, and so 9 minus 1 is equal to 8, and then the square root of 8 is 2 root 2. So now I can do, I already have cosine, I already have secant, I'm going to need the sine of theta, the cosecant of theta, the tangent of theta, and the cotangent of theta. So the sine of theta is going to be 2 root 2 over 3. The cosecant is flip that, so 3 over 2 root 2. The tangent of theta is the opposite over the adjacent. And then the cotangent is reciprocal of that. Okay? So that's what we're doing when we do this. So cosine has to be negative. That's an x-coordinate. That narrows it down to quadrants 2 and 3. Now, based on the fact that they have to be opposite signs, we're looking for a positive sign, and the only place that happens is up. Okay? So those are our 6 values, and these are the only options given the 2 requirements that we had. So in Chapter 4, all we did was look at the values. We did not manipulate them based on their identities. In Section 5.1, all we're going to look at is the identities, okay? So we review at the beginning of 5.1 by simply reminding you that you know the identities. We've memorized the unit circle. We've memorized the basic functions, opposite, adjacent, hypotenuse, and how those legs relate to each other. But now in 5.1, these identities are going to be what we have to commit to our brains, okay? So these are 2 blue boxes, and in your book, it's only 1 blue box. It's a giant blue box. But I'm going to go ahead and show you how we use these. And then tomorrow when you come in and the sub says, hey, get out your books, this is the assignment, you can go ahead and do these. Okay, so the first thing we're going to do is practice by simply rewriting identities. That's all we're going to do. And your book likes to say simplify, verify, rewrite. Any of those options is good. Okay, so keep in mind these are all the identities that we've already used in terms of what they are. But now we're going to use them not to find values, but rather just to simplify these quote-unquote expressions, okay? Notice there's no equal sign. So for me, the way that I break it down in my head is I remember that the sine and cosine are the parent functions for everything, right? And what's the mother function? Sine. So everything is going to involve sines and cosines because that's what they all boil down to. So I'm going to take tangent, and I'm going to remember that tangent was equal to sine x over cosine x. So all I'm doing is rewriting tangent. And I'm going to come over here and I'm going to take cosecant, and I'm going to remember that cosecant is really just 1 over the sine of x. And then you see something pretty, and so you get 1 over the cosine of x, which we can simplify that to be, go ahead, say it, secant x. Done. And so we only want to go as far as we can in terms of simplifying. If we can get rid of this fraction, we want to, and we can. We can make it be secant. If we can't get rid of the fraction, we should be able to, but if we can't, we would leave it, okay? If it's a mixed fraction, we want to just leave it. So now let's take a look at number 28. And these numbers are straight from your book, okay? Straight from your book. So beta here is just another way of saying x or theta or whatever. The letter is irrelevant. So cosine theta or cosine beta cannot be rewritten. That has to stay. But tangent of beta can be rewritten to the sine of beta over the cosine of beta. Remember, this letter can be anything. I don't care if you call it who cares. Doesn't matter. And so now we simplify that, and we get the sine of some letter. That's as pretty as it can get, okay? So what we're doing on the first few sets, numbers 16 to 20, and then again numbers, I think it's 22 to 28, all you're doing is simplifying. So you want to rewrite, and the way you do that is you use the identities to make them look different. Okay. Great, Coach Ray, you're in trouble. Okay, so now we're going to use the littler box. These are called cofunction. And I'm just going to draw this little triangle here for a second because I want you to remember this was 90 degrees. And when we called this theta, the way we were able to find that measurement was to take 90 minus theta. So we talked about this before where we said, oh, hey, what's the sine of theta? And we did an example like a 3, 4, 5 triangle. And so we went 3, 4, 5 and went, oh, what's the sine of theta? So we went, oh, it's opposite over hypotenuse. And then I said, okay, this other angle, what's the cosine of this other angle? And you went, oh, yeah, Ms. Collins, it's the same. Oh, yes, it is. It's exactly the same. So these cofunction identities right here are saying that without actually using numbers. Remember, we're not talking about values right now. We're simply talking about the identities. And so now what I want to do is I want to say, okay, this right here, when I see this pi over 2, remember, that's just 90 degrees. When I see the sine of this junk, I'm thinking cosine x. And when I come over here, walk, 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 over here, look. See this letter here, U? This has to be a U. If that's an X, this has to be an X. If this is a beta, this has to be a beta. The letter has to be the same. That's the only rule. Okay, so then I come over here and I see, oh, this is the cosine of pi over 2 minus x. Look over here. Ooh, right there. Cosine of pi over 2 over x. So cosine of pi over 2 minus u in this case. And that's equivalent to the sine of u, but oh no, Miss Collins, the sine of x. Because this is an x, this has to be an x. So now we go, okay, well, what identity is cosine over sine? Well, I'm going to flip back quickly. And right here, we see that cosine over sine is equal to cotangent. So I'm just going to rewrite this to be equal to cotangent of x. And that's as pretty as it gets. It does not get any prettier. Okay, so these are called cofunction identities. Again, notice we have even and odd functions. The even and odd functions. And so what we want to do is talk about, well, the ones that these right here are considered odd. And these right here are considered even. Odd, my bad. That's not. That one's even. This one's odd. Silly girl. Okay. So, okay, let's do another example. All right, so some more practice. So now we're going to start to use these ones, and these become the functions that we use, not only starting now, but all the way through calculus. Okay, so here's what I want to do. I want to see if I can substitute for this or for this. And remember, I'm trying to make it pretty. So cosine squared x looks pretty darn pretty already. So now I want to say I'm going to leave that one, and I'm going to look to substitute secant squared x minus 1. When I come over and I look at my identities, I can see this. But that doesn't say secant squared x minus 1. So now I have to think, is there a way I can rewrite that algebraically? Can I manipulate this so that I get secant squared x minus 1? And look. So now what's equal to secant squared minus 1? It's tangent squared x. So I'm going to pick this one up and I'm going to move it down for a sec. And so what I have on this side now is tan squared x, and I get secant squared x minus 1. So here's what I'm doing. I'm doing a little algebra 1 called direct substitution. I am, instead of calling this secant squared x minus 1, I want to rename it as tangent squared x. So I want to take this and I want to plug that in here. Notice that this box here and this here are equivalent. It's right here. There's that equal sign. So then I say, okay, well, that's my first substitution. But now, remember, I want to make it pretty. Well, tangent can be broken down. What is tangent? So when we go back a slide, we remember that tangent, it's right here again, tangent is equal to the sine squared of u, oh, in this case, x. If I do that, you can just flick me. It's a bad choice, Miss Collins. Over cosine squared x. And look, gone, gone. And what am I left with? Yes, sine squared x. It gets no prettier. That's it. We're done. Okay? So in my brain, the way I make it work is I break everything down to sines and cosines, because those are my favorite functions. Sine is the mother of all functions, and so we want to use her whenever possible. But not only are we going to be able to use the identities here, but we're going to be able to use our algebra 1 skills, yay, algebra 1, to factor. And this, I'm hoping some of you will remember, is just like a difference of squares. And so what I want to do now is I need to start using these identities and make some substitutions. So, let's do it this way. Let's say we have, well, I know what secant squared is. I've already used that one. So I know secant squared. So let me plug those in here and see if that helps me at all. So now I'm going to make this substitution. Wherever I see a secant squared x, I'm going to plug in 1 plus tangent squared x. So this is going to become 1 plus tan squared x. And then we still have our plus tan squared x. That doesn't change. Now over here, we're going to make the substitution again. And so we're going to make this be 1 plus tan squared x. But then this is not going to change. That's going to stay. So now look, when we start to simplify, we have 1 plus a tangent squared x plus a tangent. So 1 apple plus 1 apple is, good, 2 apples. So that becomes my first term. Now my second term, we have 1 apple minus 1 apple. Those go away, times 1. And so now when you look at that, you go, oh, hey, look, that's as pretty as it gets. 1 plus 2 tan squared x. When I come up here and I just look at my identities, I don't see that anywhere. This does not help me. That does not help me at all. Okay, I don't want to make a fraction, so I'm going to go ahead and stop. Okay, you know you're done when you don't have a fraction anymore, and there's no other simple substitution you can make. I mean, at this point, tangent squared, I could plug in secant squared minus 1, but that doesn't get me anywhere else. Okay, so I could stop here. I could write it a different way, but in this case, I'm going to go ahead and stop. Okay, so let's do one more. And we're going to use the identities again. But this time, this is a sign. And so, here's this function, this identity. So what I want to do is I want to rewrite this for sine. So sine squared x plus cosine squared x equals 1. I want to isolate the sine squared. So how do I do that? I want it to be this. Actually, my bad. I don't want that to be alone. I want to see if I can make that be 1 minus sine squared x. That's what I want to see. So how do I do that? I'm going to go this way. And so on this side, the only thing I have left is cosine squared x. And on this side, I have 1 minus sine squared. So I'm going to rename 1 minus sine squared. I'm just going to name it something else. It's right here. See this? I'm going to rename that, and I'm going to call it cosine squared x. That's what I'm going to call it. Now, I want to remember that secant squared, or even secant. What is secant? Secant is 1 over cosine. So this is going to become 1 over cosine squared x. So you have cosine squared x over 1 times 1 over cosine squared, and that's just 1. Now, look at this expression. Oh, good Lord, people. So sorry for these interruptions. It's horrible. Okay, so this ugly expression right here, secant squared x times the quantity 1 minus sine squared x, is not very pretty. But look how pretty it is when we rename it. Its new name is 1. So all we're doing in Chapter 5 for the first few sections is using identities to simplify, to rewrite, or to rename these ugly messes here, these quadratic, these, ew, ickies, trigonometric, quadratic-looking things into pretty things like, yay, the number 1. Yay, so much prettier. Okay, so now I'm going to give you the problem set, and the sub is going to have it. I didn't bring a book into this room. So the sub is going to give you. So now you're going to do bookwork. You're going to do the bookwork in class. Okay, in class tomorrow, Friday, September 13th. Got it? All right. Have a good weekend.